What if I told you that the AI model you have been paying for every single month, the one sending your data to some server halfway across the world, you could run it yourself on your machine for free? No subscription, no data leaving your laptop, no one reading your form. Sounds good to be true, right? Well, stick around because today we are going to do exactly that live on this episode. In today's episode, we are talking about one of the most important decisions anyone using AI tools needs to make right now. It sounds like a technical question. Yeah, there is some tech involved, but really, it comes down to the things everyone cares about. It's your privacy, it's your wallet, it's your time, and just how this stuff works under the hood. Here, what are we covering today? First, we'll break down what cloud AI and local AI actually mean, the tech behind them. And then the fun part, I'm going to walk you through a live demo where we download Google's Gemma model right on the local machine using a tool called Ollama. No API key, no cloud, no subscription this time. So let's start from the very beginning. When you use ChatGPT, Claude, or Gemini, what actually happens? You type something into the box, you hit enter, and then the magic, right? Not exactly. Here is what's really going on. Your message gets sent over the internet to a massive data center. Think a rows and rows of incredibly powerful computers owned by OpenAI or Anthropic or Google. These computers run the AI model, generate a response, and send it back to you. That whole process, sending your prompt to someone else's computer, getting an answer back, that's the cloud AI. The model lives on the servers, you are just renting an access to it. Now local AI. So flip that entirely. Instead of sending your prompt to a remote server, that model runs on your machine, your GPU, your CPU, your RAM, prompt that never leaves your device. Think of it like a cloud AI, like going to a restaurant. Someone else has the kitchen, the chef, and equipment. You just place the order and wait. Local AI is like cooking at home. You have got ingredients, you are running the kitchen, and no one else is involved. Both both have their place, and that's exactly where we are going to figure out today. Okay, now let's talk about some privacy over here. Because I think this is the single biggest reason more people are moving towards local AI and it doesn't get nearly enough attention. When you use a cloud-based AI tool, your prompts go through someone else's server, and yes, the most reputable companies have the privacy policies. But there is a thing. Those policies can change, data can be used for training, there can be a breaches, sending a confidential client data or an internal strategy throughout third party. Database. Ask yourself this, would you be comfortable if your company's sensitive documents, your medical questions, your private business ideas were sitting on someone else's server right now? With local AI, that question disappears entirely. Your prompt stays on your machine, full stop. No terms or service to worry, no outputs, no opt-outs to dig through, no risk your data being used to train the next version of someone else's model. For the developers building an internal tools, for the founders working on unreleased product, for the students doing research on sensitive topics, local AI is a genuine game changer for the privacy standpoint. Cloud AI typically runs on a subscription or pay per token model. You are paying for convenience, someone else manages the infrastructure, keeps the model updated, scales it for millions of users, and that's for nothing. But those costs add up. If you are a developer making thousands of API calls a day or a startup running an AI across your products, cloud cost can spiral fast. Local AI, on the other hand, has no ongoing cost per query. Once the model is on your machine, you can run it as many times you want, free forever. The trade-off, your upfront hardware matters. Running a large model locally is much smoother on a machine with a decent GPU or plenty of RAM. On older laptop, you might find the things running slower than you would like. When you send a prompt to the cloud AI, there is always some latency. Some message has to travel to the server, gets processed, and come back. On the fast connection with a lightly loaded server, that can feel a near instant, but in the near, but it is never truly real time, and it can slow down when servers are busy. Local AI eliminates the network latency entirely. The model is running on your hardware right there for many tasks. Especially with the smaller models, the response can feel snappier, but particularly for short, focused queries. Now, how does a model actually run your machine? AI models like Gemma, Llama, and Mistral are the files, big files, sure, but they are just files containing a billions of numbers called weights. When you run the model, software loads those weights into your computer's memory and performs an operation on them to generate a response, token by token. A GPU needs to speed up dramatically because GPUs are built to do many calculations in parallel. Exactly what matrix math for AI needs. But modern tools have gotten clever about running the models on CPUs too. Using an optimized formats like gguf, what compresses the quantized model so that they can run on less powerful hardware without totally sacrificing the quality. And ollama, the tool we will use in the moment, handles all of this complexity behind the scenes. And you don't need to understand quantization or gguf to use it. It just works. Stay tuned. In the next video, we'll demonstrate how to set up an ollama, how to download a model weight, how to run the models locally with ollama, and how to set up a model so that it can leverage the power of GPU. And then we will try to prompt the model with some examples and try to get an answer from it.